Hello, I'm Hazel, and today I'm going to talk about our initial results from Project PORO-CLIM. In May 2021, the PORO-CLIM project collected a new dataset across the little-studied Porcupine and Rockall Plateau passive margins in the North Atlantic. Profile 1, a 400-kilometre-long seismic profile, contains the continuous latest Cretaceous to early Eocene oceanic crustal thickness record, spanning the full North Atlantic Igneous Province cycle. Oceanic crustal thickness can be directly interpreted as a record of magma productivity and hence mantle temperature. This means that Profile 1 provides a record of the changing magma productivity during the development of the igneous province. This is the first continuous and high-resolution record of the entire waxing and waning cycle of mantle temperature during the initiation of any of the world's large igneous provinces. PORO-CLIM will also use this record to clarify the relationship between the igneous province and the PETM. Eriador Ridge, which is crossed by Profile 1 here, is thought to be the crustal trace of the pulse of anonymously hot mantle which drove North Atlantic Igneous Province still province emplacement. Thermogenic methane generated during this is the most likely carbon source for the PETM. To interpret oceanic crustal thickness and therefore magma productivity, a crustal velocity model derived from ocean bottom seismometer data is required. Modelling is currently ongoing, but in the meantime, we can instead infer relative changes in magma productivity through both qualitative assessment of OBS records and from the roughness of the top basement horizon. Data analysis can be seen on the poster, but overall, together, these indicators suggest that magma productivity increased from the late Cretaceous to early Eocene. Alongside this, on a shorter timescale, magma productivity became more pulsed. The seismic section also shows that Eriador Ridge contains a previously unknown double peak. This could potentially imply multiple plume pulses around the Paleocene-Eocene boundary. However, more detailed seismic interpretation, as well as magnetic strike modelling, is required to rule out a tectonic origin. This, alongside the full OBS crustal velocity modelling, represents the next steps for the project.